Hello viewers, today I'm going to show you how to design a simple control system, how to design it on paper and how to implement it. So what I'm going to design today, we're going to, this is an ultrasonic sensor, and we're going to program it so that it will move, it will switch a contactor or a relay, to switch a relay, and the relay will turn on this light. So we'll say that when it gets to 150 centimeters, when it goes to 15 centimeters from anywhere, anything that is detecting, the light will come on. When you move it away, the light will go off again. So here's how the ultrasonic sensor works. The ultrasonic sensor is continually emitting a sound. If you listen well, you hear a sound that is emitting. It's not emitting the sound now, but it's actually, if you listen, you hear the sound. So ultrasonic sensor is continually emitting sound, and when it emits the sound, it is a sender and a receiver. So when it emits sound, it listens and receives a feedback, and then depending on the distance that has been set, because this has a reach, it has a maximum reach. The maximum reach of this sensor, for example, I think is 30 meters. 30 meters, I think, is the maximum reach for this sensor. Should be on the data sheet. First of all, we're going to have to design this on paper, and after we'll implement it. So so the first thing is to draw the coil of the relay. The relay is what's going to switch on the light. So the relay switches on the light. The relay, this here is the coil of the relay. And we're just going to call this relay KM1. And then the sensor. The sensor is here. Now, this is going to be our sensor. So this sensor has 3 wires. So one of the wires will be the power, positive, because this sensor is a 24 volt DC sensor, and we're going to make sure that this one is also 24 volt DC coil. So it has to be 24 volt DC coil, and this one will need 24 volt here. We need to supply 24 volt here. From the 24 volt could come from a power supply unit. Let's say we have a battery here. We'll just put a battery here as our power supply unit for now. So this should be our battery. 24 volts. This is plus and this is minus. This is earth. So this is going to be our power supply to the coil, to our power supply to the sensor. So this is a sense. This is the ultrasonic sensor here. Okay, here we have the switch, and this number, if we look at the data sheet, if we look at the data sheet of the sensor, it says it's brown cable number 1, which is that. So this is number 1 brown cable. So this is cable number 1, which is brown, which is cable number 1. This is cable number 1. It's our wire number 1. And then the switch. The switch is the out. So it could be, I think it's normally open or normally closed, depending on how you. So So this is a black cable. This is the black cable. This is the black cable, which is going to be the out for us. So we might have to implement a normally open contact. And this is going to supply 24 volts. This is what's going to supply 24 volts to that our relay. So from the sensor, we're going to supply 24 volts. So when this one closes, we'll supply 24 volts. We'll supply 24 volts to the relay, we'll supply 24 volts to this relay. And this BK is number 4. It's number 4 wire. It's a black one. So, and then earth should be the blue one. So the earth, this one should go to earth. And let's say this is earth. Let's say this is the earth here. Both of them will come to earth here. So that's the relay done here. This is the relay, this is the sensor. And this is our power supply unit. PSU, power supply unit. It could be a transformer. It could be a 24 volt DC transformer. It could be any other type of power supply unit that supplies 24 volt DC. It's 24 volt DC. If you use pencil, you can always correct. So this is what we have here. We have the sensor here. We have the sensor here. We have the switch. And we have the negative pole. We have the positive 24 volt DC here. We have the minus 24 volt DC here. And then we have the coil. This is the coil of the coil of the relay. And this is a contact that we're going to use. Okay, the contact of the relay. So this contact, this is KM1. KM1. And this part of the contact, this contact is where we're going to put the light. So here is the light. Let's say this is the light here. So we're going to take, this is going to be 24 volt DC to the light, and this is going to be earth. So what we could do is that we could either supply earth, here, or we supply 24 volt AC here to this light. So I think I would prefer to supply 24 volt AC to it. So what I could do is that we could take this one. Oh yeah, we could supply earth to it through this contactor, through this relay. We could supply earth to it. So what we could do is that we take this one again to the power supply unit. We take this to the same power supply unit here. So we take it to the power supply unit here, but then the earth will have to come through here. The earth will have to come through here. And then this one will come to earth as well. So, you understand now? When the sensor closes, it supplies 24 volts to the relay. And when it supplies 24 volts to the relay will close the switch, because this already has 24 volt DC here. So when it closes this switch, it's going to supply earth. It's going to supply earth to the it's going to supply 0 volt to the light. and then the light is going to illuminate. So now we're going to build it. We're going to build it now. So this is the sensor. These are the wires that I think we're going to need on the sensor. So we have the blue one, which is the 0 volt, which is the blue here. This is the blue. It's BUE. BUE, we'll call it. So blue is the earth, is a 0 volt. Black is a switch, and brown is a positive volt. That's the 24 volt. So we're going to make use of these 3 wires to control our circuit. We're going to use this. This is a transformer, AC to DC transformer, and this transformer can only move up to 15 watts. So we have to calculate to make sure that we can that we're not going to give it too much. We're not going to consume too much. So this can be able to carry. It can only carry up to 15 watts and 24 volts. So if we do that, P, which is P is equals to I times V, right? Okay. Power is equals to current times voltage. And with this sensor runs on, I think this sensor, we're going to say this sensor is 200 milliamp. So 200 milliamp, that's 200 times 10 to raise 3 amp times 24 volts. 24 volts. If we put that on calculator, we can know how many power this consumes the sensor. So it's 200 raised to 200 times 10 raised to minus 3, 10 raised to minus 3 times 24. So we're going to have like 4.8 watts. So this sensor is going to consume like 4.8 watts. So we have to do the same calculation for the relay. So we're going to use this relay. How much current does this relay consume? So I've looked at the data sheet online, and the data sheet is saying that it could be it's saying that the power is 0.7 watts. So that means the nominal power of the coil is 0.7 watts. So that means we can actually use this so if we sum up the power consumption, we'll see that now we also have to check the light that we're going to connect, because we're going to use this power supply unit. So we don't want the load that we put on this to be too much for it. So we're going to use this light as well. And this is using 20 milliamps. So if we calculate 20 milliamps, the other one was 0.7 watts. For the coil of this relay, 0.7 watts. And here we have 20 milliamp. So we have P equals to I times V is equals to 20 milliamp, which is 20 times 10 to minus 3 amp times 24. If we do that, we can also see that we'll check how much this thing we're going to get, power we're going to consume. Is this right? Well, this is going to be 0.4. It's going to consume let's say 0.48 watts, which is 0.48 watts, and this one is 0.7 watts, and this one is consuming 4.8 watts. That's a lot. Maybe because it needs to pass power to the coil. It needs to switch circuit. That's why it's consuming a lot of power. Anyway, we're ready to build. We have all that we require. We have the power supply here, we have the coil here, and we have the light that is gonna shine. Just remember, all of them are 24-volt DC. And then we have the sensor, the ultrasonic sensor, which is going to do the switching. And we have, most importantly, we have our secret. We have a diagram here, which we are going to follow. We've just designed this, and I've shown you how it's designed. So it's not much more than this. This is a simple way to design a circuit. So now we implement it. So this is all wired up and plugged in, but I need to flick the switch now. Hopefully nothing will blow as we flick on the switch now. Hopefully, especially the transformer, but we've calculated it and we know that the transformer should not blow. So we flick the power on and see how it reacts. It's already on because this is normally close contact we use. So when it detects something. See, when it detects, it goes off. You know, when it detects, I think when it detects, it goes off. So you see the sensor is close. So when you put